Okay, what we're looking at here is the first page of our booklet. Chapter 1, Basics of Algebra and Graphing. So rather than my writing them out on the board, I have them in this format where you can actually see what we're talking about. So here are the topics covered in section 1.1. And we've looked at algebraic expressions, equations and inequalities, and sets of numbers. So the first four are based on these four vocabulary words. So question number 1, and let's get a pen going here. In the expression 4x to the third, 4 is what? 4 is the constant. In the expression 4x to the third, what is x? X is the variable. In the number or numbers 0, 15 and 3/4, these are examples of what kind of numbers? Rational numbers. And the number, the square root of 2, is an example of an irrational number. Now, what we're going to do in these next few examples, as is indicated, we are going to substitute for the letter M a 4 and for the letter N a 5. So let's go over that technique. So 3 times N, and we'll put that in a parenthesis, minus 2. Now our M is 4. Put that in a parenthesis. So this is a 15. 15 minus 8 gives us a 7 for the answer. Now here we're going to substitute a 10 for the A. So 10. And we see that A is squared, so we'll square it, plus 9, minus, and then B is 5. Now in the protocol of operations, what do we do first here? We square the 10. That gives us 100. And we're going to add it to 9. That gives us 109 minus 5, 104. And in this next one, it's a little more challenging. Here we have x is 2 and y is 3. So we're going to have 5 times 2 squared times 3 plus 3 times 2 times 3, that's squared. Again, we're trying to show you a strategy of putting them in parentheses so it really makes it clear what you need to do. So over here, we're going to square the 2 first. That is a 4. Then 5 times 4 is 20 times 3 is 60. Now here we're going to square the 9. I'm sorry, square the 3 to get a 9. 2 times 9 is 18. And 3 times 18, I believe, is, let's see, 18 times 3, yes, 54. Adding this together, we get 114. Okay, so this is an example of the kinds of things they expect that you can do in the basics of algebra. Now there's another sheet, and I believe we can get to it just by scrolling up. Perfect. And we may be able to make it a little bit bigger too so you can see it better. But let's see how this is going to work. Okay, we're going on now to item 8, where they want us to substitute these values for the letters. So let's just do some substitution. 5 times 2 times 1 here, plus 4 for z. And since this is in parentheses, we have to do this first. Then we're going to divide that by 6. So 2 times 1 is 2. 2 plus 4 is 6 times this 5 out here, and then divide it by 6. Now, notice you have to do the multiplication first. This is going to be 30. 30 divided by 6 is 5. Okay. Now, here's a case where you have to be careful. It's 5 times x. X is 6. Divided by 3 times 2. So again, from left to right, you're going to do the multiplication first. This is 30 divided by 3, and that gives you a 10. 10 times 2 is 20. All right, and this next one here. Now notice we have brackets, so 11 minus r is 3 plus s is 4, and we're going to square that, then divide that by 2, and then times it by r, which is 3. So inside the parentheses here, this becomes a 7. And we're going to say a negative 7. So 11 minus 7 is 4. 4 squared is going to be 16 divided by 2 will be 8 times 3 is going to be 24. So let's just review this one. We substituted correctly, and we're going to do the innermost parentheses first. 3 plus 4 is 7. 11 minus 7 is 4. 4 squared is 16. Divided by 2 is 8. Times 3 is 24. Okay, next one. 2 times x is 5 plus 10. That's a bracket there. And we're going to square that. All right, 5 plus 10 is 15. 15 times 2 is 30. So 30 now squared is 900. All right, this next one. 5. A is 8. Minus B, which is 3. And that's going to be squared. Minus 3, which is B, which will be squared. Okay, looking at this now, we have 8 minus 3 is 5. 5 times 5 is 25. 25 squared is 625 minus 9. That looks like it's going to be 616. Okay, now I'll have to erase these, but again, you can always reverse the tape to go back to check them out. Okay, as we continue now to example 13. They're getting a little more sophisticated. So it'll be 5 times s, which is 7, minus 3, which is our t, which will be squared, minus 2 times s, which is 7, plus 3. So here we have to keep in mind that we're going to square. This is 5 times 7 is 35, minus 3. We're going to square here 32. And I don't know that right offhand, so I'll put that in my trusty calculator here. 32 squared. That's 1024. Now this is going to be a 10 here. A negative 2 times 10 is a negative 20. So we have 1024 minus 20 will give us 1004. All right, this next one is interesting because this is the formula for a triangle. So it's 1/2 the base, which is 4.2, and then times h, which is 6. Now this will actually cancel here. So it's just basically 3 times that. So that's going to be 0.6. So 12.6. Now you could have multiplied 4.2 times 6 and then just divide by 2. That will give you the answer there. Now, they do give us, let's see if I can get rid of that. Okay, good. Some examples that use a graphing calculator. So those we just skip since we're not using that as part of our curriculum. Here they want us to find out whether each number is a solution of the given equation or inequality. Well, since this has an equal sign, this is an equation. This one is an inequality. So we want to see if, in fact, these are true. So what we basically do is we substitute the 1 where the t is. And we can do this first one, I think, mentally. This is going to be a -3 here. So 16 minus 3, is that equal 1? No. So this is no. This is going to be a 5. So -3 times 5 is a -15. And a positive 16, that equals 1. Yes, this is true. And in this case, only 1 can be true, so this is going to be not true. Now, here they've made like a little chart. We can put them in here. So here we would say no, yes, no. And if we put a 2 where the x is, this is 10. So we get 10 minus 8. Is that greater or equal to 7? Well, this is going to be 2. Is 2 greater or equal to 7? No. How about if we put a 3 there? This now becomes a 15 minus 8. Is that greater or equal to 7? Well, it happens to equal 7, so that is yes. And if one part of these are true, then it's true. And then if this one were true, so is 4. Because that'll be 20 minus 8 will be greater. Okay, here they want us to use roster notation to write each set. Okay, for these now, as we look at them, I've written them out so you have make the tape a little shorter. The set of all natural numbers that are multiples of 100 in roster notation. You put your braces, 100, 200, 300, and your ellipsis, indicating the pattern will continue. The set of all letters in the word math, you write the letters of math, separated by a comma, each letter, and again, put them in braces. And now using set builder notation, we jump down to this one. We're saying that x is such that x is an integer between -4 and 4. And then we just put our brace there, and that will wind that one up. Okay, going on to number 22, using set builder notation. We start off with a brace. X is such that x is the set of all even numbers between 1 and 11. And basically what you would do is you would just write this out. X is all even numbers between 11. Now, I didn't check on the instructions here. If they wanted it in roster form, then in roster form, you would then have to list them. And you would start with 2, 4, 6, 8, 10, and that would be the set. Okay. Now here we're looking for which are whole numbers here. Well, whole numbers, by definition, would be a number 0, 1, 2, 3. So this would be a whole number, and it's those two. So 0 and 3. Which of the following are integers? And a negative 15 would be 0 and 8. Which of the following are rational numbers? All of these are rational numbers. The only one that isn't is the square root of 5. And which is irrational down here? The square root of 3. And let's look at this last one. We're asked here for number 27, using these letters to define the sets of numbers, is a natural, or are natural numbers a subset, that's what that symbol is, of rational numbers? And that is true. Now, is, and Z is a set of integers, is 12.8 an element of the set of integers? It's not a whole number, so the answer is no. That would be not true. Okay, the next little part comes up here, and we'll do this in another tape. All right.